Welcome to MRL. In this learning session, we'll be learning the solutions of all the examples of exercise 8.3 of Trigonometry chapter of 10th NCERT CBSE textbook. Now, in the first question here, we have been asked to express T ratios sin A, sec A and tan A in terms of cot A. That means we have to express sin A in terms of cot A, sec A in terms of cot A and tan A also in terms of cot A. Now, let us first assume cot A be equal to x. If cot A is equal to x, then cot A is equal to x upon 1, but also we know that cot A is equal to AB upon AC. If you take a right angle triangle here, then cot A angle A is equal to AB upon BC, AB upon BC. So therefore AB upon BC is equal to x upon 1. That means AB is equal to x and BC is equal to 1. By applying Pythagoras theorem, we can find out AC. AC square is equal to AB square plus BC square, x square plus 1 square, x square plus 1. Therefore AC is equal to square root of 1 plus x square. So that is the first part of this example. Now to find sin A, now we have been asked to find sin A. Sin A is equal to BC upon AC. That means it is 1 upon root of 1 plus x square, but we know that x is cot A, so replacing x by cot A we get 1 by root of 1 plus cot square A. Therefore sin A is equal to 1 divided by root of 1 plus cot square A. So we have expressed sin A in terms of cot A. Now coming to sec A is equal to AC upon AB. That means it is root of 1 plus x square upon x, and x is cot A. So putting x as cot A, we get root of 1 plus cot square A upon cot A. Therefore sec A is equal to root of 1 plus cot square A upon cot A, which here I have expressed sec A again in terms of cot A. Now tan A is equal to 1 upon x, and 1 upon x is 1 upon cot A. Therefore tan A is equal to 1 upon cot A. I have expressed tan A in terms of cot A. So that is how we solve any example that we have expressed sin A, sec A and tan A in terms of cot A. Please understand that. Now coming to the next example, we have to write all the T ratios of angle A in terms of sec A. That means we have to write all the T ratios, primary T ratios and secondary T ratios in terms of sec A. Now let us assume first, let sec A be equal to x. Then what is sec A in this triangle here? Sec A will be x upon 1, AC upon AB becomes x upon 1. Therefore sec A is equal to AC upon AB, or x or AC is equal to x and AB is equal to 1. Apply Pythagoras theorem, find out BC. Then we have AC square is equal to AB square plus BC square, x square is equal to 1 square plus BC square, or BC square is equal to x square minus 1 square, or BC is equal to root of x square minus 1. So we have found out BC. So once we know the measures of AB, BC and AC, it's very simple to find out all the T ratios in terms of sec A. Now sin A is equal to BC upon AC. It is root of x square minus 1 upon x, but we know that x is equal to sec A, therefore it is root of sec square A minus 1 upon sec A. Therefore we have expressed sin A in terms of sec A. Cos A is equal to AB upon AC. Then AB upon AC is 1 upon x, and it is 1 upon sec A. So cos A expressed in terms of sec A. Now tan A is equal to BC upon AB. It is root of x square minus 1 upon 1, or root of x square minus 1, that is root of sec square A minus 1. So the tan A is equal to root of sec square A minus 1, again expressed in terms of sec A. Now cosec A is equal to 1 upon sin A, because we know that cosec A is 1 reciprocal of sin A. Therefore I can take reciprocal of this, so it will be sec A divided by sec square A minus 1. And we know that cot A is reciprocal of tan A. Cot A is reciprocal of tan A, and therefore tan A is root of sec square A minus 1 there. Therefore reciprocal will be 1 by root of sec square A minus 1. So that is how we express the T ratios in terms of sec A. Now coming to the next example, choose the correct option and we have to justify it. In the first example, in the third main first example, the correct answer is 9. The simple reason is we are given 9 sec square A minus 9 tan square A. Take 9 outside. In the bracket we get sec square A minus tan square A. But we know that 1 plus tan square A is equal to sec square A is an identity. Therefore sec square A minus tan square A is equal to 1. So 9 into 1 is 9, and that is the justification for this. Now example number 2, we have been given 1 plus tan A plus sec A in the bracket, and 1 plus cot A minus cosec A in another bracket, and the value of this will be 2, as in the choice the 2 is the correct answer. Now let us see why it is 2 there, or let us justify this. Now let us convert tan theta as sin theta by cos theta, because we know that tan theta is equal to sin theta by cos theta and sec theta is 1 by cos theta. Now converting cot theta also in terms of cos and sin, cos theta by sin theta, cosec is 1 by sin theta. Now taking the LCM is cos theta here, so cos theta 1 into cos theta is cos theta, then this remains sin theta here and 1, so cos theta plus sin theta plus 1 upon cos theta is what we get by simplification. Here the sin theta is the LCM, so it will be sin theta plus cos theta minus 1. Now taking cos theta sin theta outside, we get 1 upon sin theta into cos theta, in the bracket cos theta plus sin theta plus 1, cos theta plus sin theta minus 1. So it is taking this as A and this as B, and this is A and this is B. It is A plus B into A minus B. A plus B into A minus B is A square minus B square. So it will be cos theta plus sin theta whole to square minus 1 square, and that will be cos square theta. A plus B whole to square will be cos square theta plus sin square theta plus 2 sin theta cos theta minus 1, and we know that cos square theta plus sin square theta is 1 plus 2 sin theta cos theta minus 1 and 1 will cancel, and we get 1 by sin theta cos theta into 2 sin theta cos theta. Sin theta cos theta cancels here, so 2 into 1 is 2. So that is how we simplify, and our answer is correct, and that is the justification. Now coming to the third example, the answer for third example, the choice would be cos A. Now let us justify why it is cos A. Now we are given sec A plus tan A, sec A plus tan A in the bracket 1 minus sin A. Now sec A is 1 by cos A, tan A is sin A by cos A, we know it, into 1 minus sin A. Now it will be 1 plus sin A divided by cos A, taking LCM, then 1 minus sin A. But 1 plus sin A into 1 minus sin A is 1 square minus sin square, because A plus B, A minus B is A square minus B square. So 1 upon cos A into cos square A, 1 by cos A into, because 1 minus sin square A is cos square A, cos A will cancel, and what remains behind is cos A, and that is the choice, and that is the correct answer. Now coming to the fourth example, the answer for this is tan square A. Now let us justify this. 1 plus tan square A is sec square A, because there is an identity. 1 plus cot square A is cosec square, again an identity. And sec square A is 1 by cos square A, cosec square A is 1 by sin square A. Now taking this sin square A on the top, we get sin square A by cos square A, and sin square A by cos square A, sin A by cos A whole to square, and sin A by cos A is tan A, and tan A whole to 2 is tan square A, and that's the choice and the correct answer. The fourth example, we have to prove the identities, and you all know how to prove the identities, that is trigonometric identities. And to prove the trigonometric identities, we have to show that LHS is equal to RHS, or RHS is equal to LHS, or we can simplify LHS separately, RHS separately, and show that LHS is equal to RHS. And while proving the identities, we can use all the basics, all the known identities, and the properties of trigonometry in proving the identities. So let us understand a few examples, how to solve them, how to prove them, then you'll understand the basics very clearly. Now here we are given an example, cosec theta minus cot theta whole to square is equal to 1 minus cos theta upon 1 plus cos. That means I have to prove cosec theta minus cot theta whole to square is equal to 1 minus cos theta upon 1 plus cos theta. Now what I will do, I will take the LHS, I will simplify LHS and show that it is equal to RHS here. Now taking LHS, we have got cosec theta minus cot theta whole to square, but we know that cosec theta is 1 by sin theta and cot theta is cos theta by sin theta. I have converted the secondary ratios, secondary trigonometric ratios into primary t ratios here. The reason is answer is in primary t ratios. Now 1 upon sin theta minus cos theta by sin theta, I take the LCM here, sin theta is LCM, so it becomes 1 minus cos theta upon sin theta whole to square, and it is 1 minus cos theta whole to square, numerator square and denominator square, and that is the denominator square will be sin square theta, 1 minus cos theta whole to square and 1 minus cos square theta, because sin square theta is 1 minus cos square theta, because we have the identity sin square theta plus cos square theta is equal to 1, and therefore sin square theta is 1 minus cos square theta. Now it is in a square minus b square form, so a square minus b square is a plus b into a minus b, therefore it is 1 minus cos theta into 1 plus cos theta, so 1 minus cos theta cancels with the square term here, therefore only 1 minus cos theta will remain with 1 plus cos theta in the denominator, therefore the answer is 1 minus cos theta upon 1 plus cos theta, and that is equal to RHS. So that is how we prove the identity. Now we have proved here that cosec theta minus cot theta whole to square is equal to 1 minus cos theta upon 1 plus cos theta, and that is the method of proving the identity. Now let us go to the next example. Again here we have to prove cos A upon 1 plus sin A plus 1 plus sin A upon cos A is equal to 2 times sec A. So let us take LHS. So LHS is cos A by 1 plus sin A plus 1 plus sin A upon cos A. Take the LCM. LCM is cos A into 1 plus sin A, and here cos A is not there, so multiply by cos A. Cos A into cos A is cos square A. Here 1 plus sin A is not there, so multiply by 1 plus sin A, you get 1 plus sin A whole raised to square. Now open this A plus B whole raised to square form. It becomes 1 plus sin square A plus 2 sin A. Now sin square A plus cos square A is 1, and 1 here 2 sin A, that means 1 plus 1 becomes 2, divide plus 2 sin A. 2 is common, take 2 outside, 1 plus sin A, and in the denominator we have got 1 plus sin A, in the numerator we have got 1 plus sin A here, so cancels, it becomes 2 by cos A. 2 by cos A is equal to 2 into 1 by cos A, and 1 by cos A is sec A, therefore the answer is 2 sec A, and that is the RHS, and that is what is the proof of this particular identity. Now coming to the next example, another important identity, we are given an example here, tan theta by 1 minus cot theta plus cot theta by 1 minus tan theta. We have to prove that it is equal to 1 plus sec theta into cosec theta. Now let us understand this, and it is slightly lengthy. Let us understand step by step. Now take LHS, tan theta by 1 minus cot theta plus cot theta by 1 minus tan theta. Now what I am trying to do here now is convert all of them into primary trigonometric ratios. So tan theta becomes sin theta by cos theta, cot theta becomes cos theta by sin theta, cot theta is cos theta by sin theta, tan theta is sin theta by cos theta. Now sin theta, please understand here, this is sin theta by cos theta, taking the LCM, LCM is sin theta, so it becomes sin theta minus cos theta by sin theta. Here cos theta is the LCM, taking cos theta here, it becomes cos theta minus sin theta by cos theta. Now this is sin theta here, this sin theta will go on the top, so we will have sin theta here, so sin theta by sin theta minus cos theta, and it will be sin theta by cos theta into sin theta by sin theta minus simple algebraic simplification, so apply that. Then this will be cos theta by sin theta, this cos theta will go on the top, divided by cos theta minus sin theta. Now sin theta into sin theta is sin square theta divided by cos theta in the bracket sin theta minus cos theta, cos theta into cos theta is cos square theta divided by sin theta in the bracket cos theta minus sin theta. Now if you observe here, this is sin theta minus cos theta, this is cos theta minus sin theta. I cannot take the LCM, so I will convert this into sin theta minus cos theta. When I do that, I have to take the minus sign outside, so I have taken minus, so plus becomes minus there. So I have got sin square theta divided by cos theta in the bracket sin theta minus cos theta minus times cos square theta divided by sin theta into sin theta minus cos theta. Now we have the LCM. If I take the LCM now, the LCM is sin theta into cos theta into sin theta minus cos theta, and that is the LCM I have taken. Now since here the sin theta is not there, multiply by sin theta here becomes sin cube theta. Here cos theta is not there, multiply by cos theta it becomes cos cube theta. Therefore in the numerator we have sin cube theta minus cos cube theta divided by sin theta into cos theta in the bracket sin theta minus cos theta. Now here it is a cube minus b cube form. We have to know the algebraic identity now. A cube minus b cube is equal to a minus b in the bracket a square plus ab plus b square. Apply this identity for the numerator. So it becomes sin theta minus cos theta here, then a square is sin square theta plus sin theta cos theta plus cos square theta. Now if you observe, sin theta minus cos theta and sin theta minus cos theta will get cancelled, and what remains is sin square theta plus cos square theta plus sin theta cos theta divided by sin theta cos theta. But we know that sin square theta plus cos square theta is 1 plus sin theta cos theta divided by sin theta cos theta. Now dividing 1 by sin theta cos theta by sin theta cos theta, we get 1 by sin theta cos theta plus 1, and 1 by sin theta cos theta can be written as 1 by sin theta into 1 by cos theta, and 1 by sin theta is, as you know, cosec theta, 1 by cos theta is sec theta, therefore it becomes cosec theta into sec theta plus 1, or 1 plus sec theta into cosec theta, and that is exactly what we wanted as RHS, and that is what is the proof of this identity. It is simple, but you have to understand, have patience, go step by step and prove it or solve it. Okay, understand that. Let us go to the next example. Now we have to prove here 1 plus sec a upon sec a is equal to sin square a by 1 minus cos a. We can take LHS, prove it and show it as RHS. We can take RHS, show it as LHS. But here I have adopted a slightly different method. I am going to prove LHS separate. I am going to solve LHS separately and RHS separately and show that they are equal. So let us take LHS first. 1 plus sec a by sec a, and sec a can be written as 1 by cos a, and sec a can be written by 1 by cos, can be written as 1 by cos a. Now take the LCM here. So LCM will be cos a, so it will be cos a plus 1 by cos a, and 1 by cos A, and we are taking the reciprocal here and multiplying it. Division can be multiplied. So cos A plus 1 by cos A into cos A by 1. Cos A cancels. We get 1 plus cos A, and that is the LHS. Now take RHS. RHS is sin square A by 1 minus cos A. We know that sin square A is 1 minus cos square A because of the identity. So 1 minus cos square A by 1 minus cos A, but this is A square minus B square form. Therefore 1 minus cos A into 1 plus cos A divided by 1 minus cos A. 1 minus cos A, 1 minus cos A cancels. So 1 plus cos A we get. So we have got RHS also as 1 plus cos A. LHS is 1 plus cos A, and RHS is also 1 plus cos A, but natural LHS is equal to RHS. Rather 1 plus sec A upon sec A is equal to sin square A upon 1 minus cos A is proved. So please understand this example. Now coming to the next example. The example is, that is fifth example. We have to prove cos A minus sin A plus 1 upon cos A plus sin A minus 1 is equal to cosec A plus cot A. So let us understand this. Okay, let us see how it can be done. Now here if you see, here we have cosec A and cot A, here we have cos A and sin A. So we have got the secondary T ratios here, the primary. So let us convert this into secondary T ratios, that is in terms of cosec A and cot A, and we can do it. Let us see how to do it. So what do you do? Divide the numerator by sin A and denominator also by sin A. So when I divide, I have to divide each term. So cos A by sin A minus sin A by sin A plus 1 by sin A. Similarly, cos A by sin A by sin A minus 1 by sin A. And we know that cos A by sin A is cot A, sin A by sin A is 1, 1 by sin A is cosec A. Same way here, it is cot A, it is 1, and it is cosec A. So you have got it cot A and cosec A form here. Let us see further what to do. Now cot A plus cosec A minus 1 divided by cot A minus cosec A plus 1. Now we know that we have an identity, and we know the identity that 1 minus cot square A is equal to cosec square A. So I can replace 1 by cot square A minus cosec square A. I have replaced 1 because of the identity. We know the identity that 1 plus cot square A is equal to cosec square A. Therefore cot square A minus cosec square A, we get it as 1. So the sign will change to plus because I have reversed it. I have taken cot square A plus cot square A minus cosec square A, and therefore I have to change the sign here. If I had taken cosec square A minus cot square A, then the minus would have remained, but I have changed into, I have reversed it, so therefore it becomes positive. Now we get cot A plus cosec A plus in the bracket cot square A minus cosec square A, and it is A square minus B square form. You know what is A square minus B square? It is A plus B into A minus B, and therefore we get cot A plus cosec A and cot A minus cosec A. Now if you observe here, cot A plus cosec A is common in both the brackets here. I can take cot A plus cosec A outside, and what I get in the bracket is 1 plus cot A minus cosec A, and in the denominator we have cot A minus cosec A plus 1. If you observe the numerator, this bracket and the bottom, that is the denominator, both are same. I can cancel them, so I have cancelled them. So we get cot A plus cosec A. Therefore the answer is cot A plus cosec A in the RHS, and that is exactly what we wanted and what we wanted to prove. So please try to understand why I replaced 1 with cot square A minus cosec square A here, and this is the only step which you have to be careful and understand that. Okay. Now coming to the next example, the example number 6. We are given root of 1 plus sin A upon 1 minus sin A. We have to prove it as sec A plus tan A. Now let us take LHS. Square root of 1 plus sin A divided by 1 minus sin A. Whenever you have a square root example, try to eliminate the square root, and that can be done only by rationalization, and that is how, let us see how it is done. Square root of 1 plus sin A divided by 1 minus sin A, take the conjugate of this. If it is 1 minus sin A, take it as 1 plus sin A, 1 plus sin A. So multiply this becomes 1 plus sin A into 1 plus sin A becomes 1 plus sin A whole raised to square, and this is A minus B, A plus B, therefore A square minus B square, that is 1 minus sin square A, and we know that 1 minus sin square A is equal to cos square A, so I replaced it with cos square A. Now square root of 1 plus sin A whole raised to square is 1 plus sin A, and square root of cos square A is cos A. See how the square root is removed. So we have removed the square root. That is the first step here. Now we know that 1 plus sin A by cos A is 1 by cos A plus sin A by cos A, and 1 by cos A is sec A, and sin A by cos A is tan A, and that is exactly what we wanted, and that is what is the proof of that. So please remember this. Now coming to the next example, example number 7, we have to prove that sin theta minus 2 sin cube theta upon 2 cos cube theta minus cos theta is equal to tan theta. Now take LHS. Sin theta minus 2 sin cube theta divided by 2 cos cube theta minus cos theta. Now in this sin theta is common, in this cos theta is common, so take sin theta by cos theta outside, and sin theta outside and cos theta also outside. What remains is 1 minus 2 sin square theta, and what remains inside is 2 cos square theta minus 1. Now we know that sin theta by cos theta is tan theta, and very interestingly, the answer is already visible to us. See, tan theta is visible to us. So now somehow we have to get cancelled. We have to cancel this. This u has to be cancelled. Let us see how we can cancel it. Now 1 minus 2 sin square theta, one can be the identity can be written as sin square theta plus cos square theta is equal to 1. Therefore I have replaced 1 by sin square theta plus cos square theta here, minus 2 sin square theta. Now sin square theta and minus 2 sin square theta, so subtract it. So we get cos square theta minus sin square theta and 2 cos square theta minus 1 as it is. Now since I have cos square theta at the bottom, I have sin square and cos square in the numerator. Let me convert this into cos square. So sin square is 1 minus cos square theta. So simplify it. It becomes cos square theta minus of, in the bracket, 1 minus cos square theta divided by 2 cos square theta minus 1, and open the bracket now. Cos square theta minus 1 plus cos square theta. Cos square theta plus cos square theta is 2 cos square theta minus 1, and 2 cos square theta minus 1, and the bottom 2, that is the denominator 2 cos square theta minus 1 gets cancelled, and what remains behind is tan theta, and that is exactly what we wanted. That is the RHS. A bit of understanding of the basics of trigonometry will help us to solve the identities. Now coming to the next example. The example is we have to prove that sin A plus cosec A whole to square plus cos A plus sec A whole to square is equal to 7 plus tan square A plus cot square A. Okay, let us understand this. So take LHS first. LHS is sin A plus cosec A whole to square plus cos A plus sec A whole to square. Now expand it. So A plus B whole to square means it will be sin square A plus cosec square A plus 2 sin A cosec A and cos square A plus sec square A plus 2 cos A sec A. Now sin square A plus cos square A, see here it is there, sin square A plus cos square A is written together, and cosec square A is there here, and sec square A is here, and then we have got 2 sin A cosec A, and cosec A is 1 by sin A, and 2 times cos A, and sec A is 1 by cos A. Now this gets cancelled here. Now we have got sin square A plus cos square A is 1, cosec square A plus sec square A, and this will be plus 2 and plus 2. So 2 plus 2, 4 plus 1 is 5, 5 plus cosec square A plus sec square A. But we have to get 7 plus tan square A plus cot square A. Here I can convert cosec square into cot square A by using the identity that 1 plus cot square A is cosec square A. Therefore replacing cosec square A by 1 plus cot square A, and also we know that sec square A is 1 plus tan square A. So replacing sec square A by 1 plus tan square A, I get 5 plus 1 plus cot square A plus 1 plus tan square A. So 5 plus 1 is 6, 6 plus 1 is 7 plus tan square A plus cot square A, and that is exactly what we have been asked to prove, and that we have proved it. It is, the answer is 7 plus tan square A plus cot square A, and that is the RHS. So therefore the identity is proved. Now remember that. Now coming to the next example, that is example number 9, we have to prove cosec A minus sin A bracket, in the bracket again sec A minus cos A is equal to 1 by tan A plus cot A. So let us understand this. Now here again I will adopt a different method, that is I will find the simplification of LHS and RHS separately. So take LHS here, cosec A minus sin A in the bracket sec A minus cos A. Now write this in primary T ratio, 1 by sin A minus sin A, 1 by cos A minus cos A. Take the LCM, sin A 1 minus sin square A. Take the LCM, cos A 1 minus cos square A by cos A. And now what you can do is 1 minus sin square A is cos square A by sin A, and 1 minus cos square A is sin square A by cos A. Cos square A, this power cancels here, cos A cancels with the power, and sin A cancels with the power, and therefore we get cos A into sin A. So the simplification of LHS has given me cos A into sin A. Now take the RHS, 1 by tan A plus cot A, write it in terms of trigonometric ratios sin A and cos. So 1 by sin A by cos A plus cos A by sin A. Take the LCM, sin A cos A, so it becomes sin square A plus cos square A, and we can take the reciprocal and make it as a multiplication. So it will be 1 upon sin square A plus cos square A into sin A into cos A, and sin square A into cos square A is 1, so sin A into cos A by 1, that is equal to sin A into cos A, and that is the solution or simplification of the RHS. Now we find that LHS is cos A into sin A, and RHS is also cos A into sin A, therefore LHS is equal to RHS, and that is how we have proved this identity. Remember that. Now coming to the example number 10, we have been given here to prove 1 plus tan square A upon 1 plus cot square A is equal to 1 minus tan A by 1 plus cot A whole to square is equal to tan square A. Now I have to prove that this is equal to this and this is equal to this, or rather even if I prove that the first one is equal to tan square A, the second one is equal to tan square A, that means I have proved all them to be equal. So let us take the first one, that is 1 plus tan square A upon 1 plus cot square A is equal to 1 plus tan square A divided by 1 plus 1 upon tan square A, taking the reciprocal of cot square A. Now take the LCM here, 1 plus tan square A plus 1 divided by tan square A, and you find that take the reciprocal of this 1 plus tan square A upon 1 plus tan square into tan square A. This will cancel, we get tan square A. So we got tan square A there. Now take the second one, 1 minus tan A upon 1 minus cot A whole to square is equal to 1 minus tan A, writing cot A in terms of tan, 1 minus 1 by tan A whole to square, that will be 1 then taking the LCM tan A minus 1, and taking the reciprocal here again 1 minus tan A by tan A minus 1 into tan A whole to square. Then this I can take the minus sign outside and convert this tan A minus 1 into 1 minus tan A. So 1 minus tan A divided by 1 minus tan A with the minus sign outside, this gets cancelled and we get here tan A whole to square. So therefore minus into tan A whole to square and minus tan A into whole to square is equal to tan square A, and that is the answer. So in the first case also we have got tan square A, in the second case also we have got tan square A. That means both of these are equal to tan square A, and that is the how the identity is proved. So this is an exercise where the identities of trigonometry are proved. These are only a few examples. It gives us an idea as to how to solve the trigonometric identities. You have to practice them. Practice the more number of identities. The more you practice, easier it will be for you. So practice more number of identities and learn how to prove the identities. Small clues here and there will help you to understand the proofs very easily. So practice them, note down these in a book, and keep them for your future reference. Okay, thank you.